So, as the name itself indicates, the network layer basically responsible for delivery of packets from source to destination. So, for instance, if you want to send a post, so usually how we actually make sure that like it is reaching from source to destination, like usually based on addresses. Address.
Yes.
So this network layer basically works on that aspect. Okay.
Yes. So packets means messages, sir.
Right. So when we say that like voice signal, for instance, okay, voice. So in this voice signal, we will have some analog signal like this, right? So what we do, like we saw in the initial classes, we quantize it. We actually like we
Quantize.
sample it, then we quantize it, and for this particular signal, we will say that like it is like 101101, some
In
8 bit or like uh, 8 bit or 16 bit we encode, right? So this is our message.
yes.
So when we want to send this message, we have to add some headers like address, or we have to add some CRC, correct? So
Yes.
together, it is actually we call it as packets, data packets. So I mean, in
Yes.
case of like data link layer, we also call it as frames, right? So there is a concepts of frames and packets.
Mm.
Okay.
Yes.
So in network layer, always we talk about host to host, host to host, in the sense from one computer to another one computer to another computer. So let me take like this Zoom call itself. So whatever I'm speaking, it is converted into packets, and I'm using some broadband providers, ISP based like broadband. So those packets will go through that path, and like there will be some centralized server that is actually like who is facilitating this call. Zoom is facilitating us this call, right? So
Yes.
all our packets will go to the Zoom server, and from that server again send to you. So the Zoom software will take care of it, actually, like where to send, correct? So our packets will be appended with that particular address. The same way, always all the communication will happen from one point to another, that is from one computer to another computer. Okay.
Yes. Yes.
So currently, like, which is enabling us this actually? Internet, correct? Internet.
Internet. Yes.
So network layer mainly it is related to internet itself. Okay.
Yes,
So
sir.
as I said, like it's like not. I mean, it's like there is no direct connection of the link between my computer and your computer, right? So there will be a lot of like local area network. In my home itself. I have LAN. So through that LAN is going to my city's centralized ISPs. From that server, like there will be like somewhere in the Bangalore, Hyderabad, there will be centralized server. So from that server again it will go to Zoom. So Zoom to again it will come back to Bangalore server, and like again your ISP, and then it will come to your PC. So it is not direct communication, right? So for this
Yes.
kind of multiple communication hierarchy, we always have a global addressing scheme. Global addressing scheme. Global addressing scheme. So that we call it as logical addressing. Logical addressing. Okay.
Yes.
So can you tell me which is the logical addressing we use nowadays? This IP address, right? We always talk about IP address of a PC. So if you
Yes, sir.
type in Google browser, know my IP, what is my IP? So you'll get your PC's IP. So basically, IP address is the one what we are using for it is in the network layer of TCP/IP protocols. Okay.
Yes, sir.
So let me just show you one block diagram how exactly that communication happens. So here you can see, right? So your one PC is there. So from there, actually, like it goes to router. So internet service provider, like your ECT fiber or halfway, it will go to that point, and again their servers, like between the multiple ISPs, and again like somewhere BSNL might be providing centralized cable. And other, I mean, in case of mine, like we here locally with channels, Geo, like that. So to that ISP, the packets will come. But everywhere you can see that data link and physical link. So, and here basically we will add that network link, application
Net.
transport network. But here onwards, when we transmit, right? So mostly we deal with network everywhere in these nodes. It will be like network, data link, and physical layers on. So in these devices, there won't be application. Okay. Only at the end nodes only we will have other two links. Apart from that, like in all the communicating devices like switches, routers, and all, so we will just have network, data link, physical. Okay.
Yes, sir.
So here, right, between these two nodes, the data link layer facilitates, like from this point to this point, how to transmit. Okay. Apart from that, like network layer is only for end to end. So data link layers facilitate from this point to this point, and from this point to this point. That way. Okay.
Yes, sir.
So if you see this particular image, so the data from another protocol, like upper layer, it will come to our network layer. So here, how we have to route to particular destination, it will have a routing table information. So this information will be added with the message. So if you see here, only green color, right? So when it came to this layer,
Yes.
so this pink color is added. So that is actually routing information. So how that has to go, like from this point to next server to how it has to go. So that information will be added in the network. At the destination
Yes.
address, so you will get IP packet. It will process the data and it will remove all the header information into the destination.
Yes, sir.
And actually, you may know that like if I send like there will be large set of data, right? If I send all the packets serially, then it takes a large amount of time. So you assume.
Time.
So if I assume I have one small road,
Mm.
okay. If I want to pass this vehicle, I want to reach here. Okay? I want to reach here. So if I want to send a car from one by one, so it will be going to this point, but it is actually only one road, only one by one it can go, right?
One bank. Yes, sir.
So now if I allow, like if I have some shortcut road like this, and one I have another longest route like this.
Mm.
So even with this also, even though this is wrong, I mean now if I have 10 cars, if all the 10 cars like takes these different routes, so how fast I can come to this point is like optimized, right?
Yes, sir.
So that is actually the concept of packet switching. So packet switching, what we do, we will like, there will be like, you assume I have 1 MB of data. Okay, 1 MB of data. What I'll do, I will make something like 100 KB of small chunks, and I will push into different paths. Okay, so that at
Yes,
the
sir.
destination end, I can have like less time to reach, because it has like, it takes different paths, and like it takes multiple streams of data, right? So it is
Yes.
basically making our network more efficient.
Yes.
But very important thing, whenever you packetize the things, right? Whenever you are packetizing, you have to add suitable sequence number. Okay.
Yes, sir.
So in packet switching, we have two types of packet switching. One is connectionless packet switching. Another is connection oriented packet switching. Okay. So in the connectionless packet switching, right, each packet will contain entire routing information, like from each point, right, like through which adapter, switches, router it has to go. Each information will be there in the connectionless packet switching. Okay.
Yes.
Address of each points. Okay.
Yes, sir.
So basically, the headers will contain source address, like where it is generated, destination address, where it has to go, and how many packets, total number of packets, how many packets are there, and sequence number. Why we want sequence number? For reassembly.
Yes, sir.
In the connection oriented packet switch, right? In the connection oriented packet switch, so here we will not take the different route. I mean, there will be destination routes also, multiple routes, but it is like not something like randomly we are sending. So in the connectionless packet switching, I can like send in any order, 7 packet, 8 packet, 4 packet, 3rd packet, randomly I can keep sending, because it each has sequence number. But here, not the case. So the algorithm decides this particular sequence has to go in which direction, and it is like predefined path for it. Okay.
Yes.
And like it, the algorithm takes each packet and it numbers it. It's not sequential way of numbering. Okay.
Yes.
So whenever we want to send data, like you might have heard frequently, we are using something called IPv4 address. IPv4 address. Okay. So you see that, like, right, 192.168 dot, that kind of IPs you see. I mean, in the college
Yes, sir.
networks, and like IPv4, and another is IPv6. The IPv4 is actually 32-bit address. Okay. So it
Yes, sir.
is unique number. Unique number, and it universally defines a connection to a particular device, like your computer. Okay, IPv4 address is a unique number. Okay. So IPv4 number, whatever the connections are, it is like defines only one internet, one connection in the whole internet. Okay, and two devices, like my IP and your IP cannot be same. Okay.
Yes.
So if a protocol uses n bits, okay, then our
Yes.
IPv4 address space is basically 2 to the power n. Okay. So
Yes.
in our IPv4, we are using 32 bit. So how many
Yes,
different addresses I can have? 2 to the power 32?
6. 2 to the power 32.
Correct. So it is actually 494294967296. It's 4 billion divided.
Yes.
So can connect 4 billion. Now actually the devices sizes are increasing. I mean, you will have one smartwatch, you will have one laptop, you will have one mobile. So more and more devices are getting added to the space. So there will be some strategies to mitigate this. Okay. So right now we have the restriction. Only whole world we can have 4 billion data.
Yes, sir.
So usually you see this kind of address, right? 128.11.3.31, something like this, right?
Yes.
So this is actually basically in the core network layer, it is converted into binary. 128 means 100000000. Same way 11's binary value, 3's binary value. So each actually how much bit? 8 bits. Okay.
Yes.
So when I say 8 bit, what is the maximum value I can have here?
32.
No, 8 bit. So 256 is the maximum value.
Okay. So how's
So if it is 8 bit, right?
yes,
What
sir.
is the maximum value? 2 to the power 8, right?
2 to the power 8. Okay. Yes, sir. Yes.
255 is the maximum.
Yes.
There are some problems you have to solve. Okay, so I'll just
Yes.
tell you how we can. So there are some bytes. You have to find the equivalent. Let me present the problems directly. For this, actually, we have to find the dotted notation. Tell me how to do.
Like first ones.
Yes. How much is this? It's 128, right? I think 120. If I'm not wrong. If I'm wrong, you please correct me. 128.1011. That is B dot. That is 12, right? 12. Then 11 dot 11 dot. How much it is? You can compute. I think some value. Okay. Just compute. So that way you have to compute. So same way you have to convert this also into binary. You know that like mechanism, right? And calculator also you can do.
Binary notation. Yes, sir. So for the first one, like we have to number like 0, 1, 2, 3, 4, 2 to the power of 0, 2 to the power of 1.
No,
Like
this
that one, sir.
also you just directly in the calculator you compute what is the decimal equivalent. So this is actually decimal equivalent of this. What is that? 128 is the decimal equivalent. 129
Yes.
actually. 129. Right?
Yes, sir.
This is 11. 11. in decimal. So in calculator, you will
Yes,
have
sir.
binary to decimal, and directly you have to convert. Okay.
Yes, sir.
Also, you have to convert from decimal to binary, and you have to represent.
Yes, sir.
So find the error if any of these following IPv4 requests. Can you tell me what are the errors? Whether A has any error? No, looks good, right?
How do we get to know, sir, if error is there or not?
Actually, anything which is greater than 255 is erroneous. So if you see here, all the numbers are below 255. So this also doesn't have any error. But it has error actually. So you can see 2, 3, 34.7.8. This fifth one should not be there, right?
Yes, sir.
Only 4. So 32 bit. So this is a erroneous error. What about this?
No errors. The error is there. The 301.
3 not error. What about this?
Error is there.
This is like not a valid, right?
Yes, sir.
So this address space, right? Even the 4 billion address space is there. So whenever you come to industry, so you see that like all address will not be used for all the application. So that we call it as classful addressing. So some dedicated addressing is there. So if it is local addressing, usually we go for 192 series. If it is a global addressing, you will see like 100 plus 1, right? So this is the differentiation. You can see 0 to 127 one group, 128 to 191 one group, 192 to 223 one group. So they have grouped actually class A, B, C, D, E. Okay.
Yes,
So
sir.
all will not be used for all. Actually, in your local LAN and all, you use 192.168 dot in that way.
Yes, sir.
So this is also one question you may get, like identify the classes, what class it belongs to. So here 0, 1, correct? So that is actually class A, right? First byte only you have to see where class A. 110, so class C, correct? Let's see. 14 is again class A. 252, this falls under this, so class E. Hope you got it.
So can you explain once again, sir? See, 14 thing.
Yeah, so see here we have table, right? So this is actually left side is in binary, right side in decimal. So first byte
Yes.
14, which falls under A, right? 0 to 127
Yes.
people, which falls. So you have to just see
Uh,
first byte, rest of the bytes.
yes, sir. So for A option, we have to convert into like numbers, sir.
Or else like that table is there, right? So you can just refer the left side table, see A. Any first bit is 0 means directly it is class. If it like first 2 bits are 10 means class B. 110 class C. That.
Yes, sir.
So in each byte, right? So they have defines like they define whether it is a net ID or host ID. Okay? So it is actually like in the class A, first byte defines the net ID. Okay, these three defines host ID. In B, 2 byte defines the net ID. These 2 defines host ID. See, first 3 you can see whichever the yellow color is, right? Is the host ID.
Yes, sir.
Rest of the things net ID. Okay. So there is another concept called subnet.
Yes.
So what they do, right? So in overall internet, multiple devices are there. Till this point where you receive the internet, they will have one logical addressing. After that, internally, right, you will have like you can use this 192 series or 127 series, how much ever you want. So it won't be global actually. Okay. Till this point, only global. Whatever the input is there, right? That one.
Yes.
Okay. Okay. A few more things maybe like we will discuss in tomorrow's class. Okay.
Yes, sir.
Okay.
Okay. Thank you.
So this recording you want?
Yes, sir.
Okay, I'll share it.
Okay, sir. Thanks.